electricity of grade 10. Can we move to the first question? This question was asked in the year 2015. Can we move to the question? This is, there are 3 resistors of 3 ohm each are connected to a battery of 3 volt as shown. Calculate the current drawn from the battery. Here we have 3 resistors connected. We can see that this R1, R2 and R3. These 3 are connected and there is a potential difference of 3 volt and a key is also connected to the circuit. Okay, here we have to calculate the current drawn from the circuit. So that how we can calculate the current drawn? Yes, that I is equal to V by R, isn't it? So for finding current, we have to find V and R. V is already given as 3 volt, then only R we have to calculate. So, how the resistors are connected here? Here consider the first 2 resistors. How they are connected? They are connected in series, right? That is end to end connection we can see. So that means R1 and R2 are connected in series. How we can find the effective resistance? Yes, that will be R1 plus R2. Each resistors are having 3 ohm, right? So what will be the answer? R12. We can represent it as R12. That is equal to R1 plus R2. That is equal to 3 ohm plus 3 ohm. That is equal to 6 ohm. Is it clear? Now, have it finished? No, we have one more resistor. That is R3. That is across. That means R1, R2, which is parallel to this R3. So, what will be the effective resistance? How we can calculate the effective resistance in the case of parallel combination? Yes, that is Rp will be equal to R1 R2 divided by R1 plus R2. That is 1 by Rp is equal to 1 by R1 plus 1 by R2. That we have studied, right? So, to calculate Rp, we can use this equation R1 R2 divided by R1 plus R2. So, we can consider these two, R3 and R12. This we have already calculated. So what we will get? R123, that is equal to R12 into R3 divided by R12 plus R3. Clear? So can we substitute the values? R12 we have calculated as 6 ohm. So that 6 ohm into 3 ohm divided by 6 ohm plus 3 ohm. So what we will get? That is 6 into 3 divided by 6 plus 3, that will be equal to 2 ohm. Right. Now we have calculated R. Now how we can find the current? Yes, that is V by R. So can we substitute? Yes, that is V is 3 and R is 2. So 3 by 2, that will be equal to 1.5 amperes. So that is the current drawn from the battery. Should I repeat? Yes. That is, here we have to find the current drawn from the battery. For that, we can use the equation I is equal to V by R. So, V is given as 3 volt and R value we have to calculate. Here 3 resistors are having the value 3 ohm and 2 are connected in series and the third one is connected parallel to the 2 resistors. So, in the case of series resistors, we can find R12 is equal to R1 plus R2, that is 3 plus 3. That is equal to 6 ohm and the third one is parallel to that. So that value is R12 into R3 divided by R12 plus R3. That will be equal to 6 into 3 by 6 plus 3. So that value is 2 ohm. Now we can substitute. So what we will get? I is equal to V by R. That is 3 by 2. That will be equal to 1.5 amperes. Is it clear? This question was asked in the year 2014 and 2011. Okay, this is very important question and this type of questions we can expect for your board exams. Okay, can we move to the question? The question is, study the following circuit and calculate the potential difference across 5 ohm resistor. So the circuit is given here. We can see the circuit diagram. That is 3 ohm, 4 ohm and 5 ohm. That is connected here and the potential difference is 3 volt. It is connected to a key. Now it is a closed circuit. Okay, so the current flows through the circuit. Now here we have to calculate the potential difference across 5 ohm resistor. So how we can calculate? The potential difference we have to calculate by using the equation V is equal to I into R. Okay, so that the I and R we have to find. So what is the current? Here the current will be V by R. So again we have to find the resistors. So here the three resistors are connected. How it is connected? Yes, this is end-to-end connection, right? So in the case of end-to-end connection, this is a series circuit. So what will be the effective resistance? That is Rs is equal to R1 plus R2 plus R3, right? So how we can calculate the resistor? Yes, that is Rs is equal to 3 ohm plus 4 ohm plus 5 ohm. That is equal to 12 ohm. So that is the effective resistance in the case of series combination. Now we have R, but for finding V, we have to get I also. So in the case of a series circuit, how the current will flow? Yes, the current will be same throughout the circuit. That means across each resistor, the current will be the same. So how we can calculate the current? Yes, I is equal to V by R. So V is given as 3 volt, isn't it? So 3 by 12 ohm. So that value is 0.25 amperes. Okay. Now we have both values of I and R. So can we calculate the potential difference? Yes, that is V is equal to IR. Potential difference is equal to current into resistance. So that we can substitute the values. So what we will get? That is I is 0.25. So 0.25 into R. So that R is 5. Because across 5 ohm only we have to find the potential difference. Because the potential difference will be different for each resistors. So this is a series circuit, isn't it? So the value is 1.25 volt. So that is the answer. Should I repeat? Yes, that is here we have to find the potential difference across 5 ohm resistor. Right. For that we have to use the equation V is equal to IR. Here the value of resistance can be calculated by using the series combination. Here the series combination is given for this 3, 4 and 5 ohm resistors. So we can calculate it by adding these 3. That is 3 ohm plus 4 ohm plus 5 ohm. Then we will get 12 ohm. Then current can be calculated as V by R. Here V is 3 and R is 12. So 0.25. When we substitute these two values in V is equal to IR, we will get the answer, that is 1.25 volt. Is it clear? Now we can wind up the video. If you like my video, please like, share and subscribe. Thanks for watching.